Then we are going to move on to calculation of velocity. Velocity. How we can calculate velocity. Calculation of velocity, that is as an application of differentiation. So I want us to look at how we can calculate velocity. And I would like us to consider this equation. Consider this equation so that you can get to know how we calculate the velocity by differentiation. So you consider an equation whereby distance, our s is the distance, is equal to 2t plus 2. 2t plus 2, whereby this is a body moving, a body covering a distance s, where s is the distance, or we can call it the displacement, where s is the displacement in meters, and then t is the time in seconds. T is the time in seconds. Now I want us to use this equation. This is an equation of displacement, and we have time. We use this to calculate velocity. We use that equation to calculate the velocity. So in this, before we get even to differentiation, we know very well that when we plot a graph, when we have a graph of displacement, a graph of displacement against time, a graph of displacement against time, from your knowledge, previous knowledge in linear motion, for a graph of displacement against time, the slope gives us the velocity. The slope will give us the velocity. The slope or the gradient will give us the velocity. And we first want to confirm that and see which other way can we use to calculate velocity by now differentiation. So we simply move ahead and plot that graph. We can have like 4 points, whereby we have our equation s is equal to 2t plus 2. So we can have a table whereby we have time and we have the displacement, so that we can plot a displacement time graph. When time is, we can start with 0. When time is 1 second, 2, up to 3. So when t is 0, we are going to have 0 times 2, then plus 2. When t is 1, we have 2 plus 2, 4. When t is 2, we have 4 plus 2, 6. And when t is 3, we have 6 plus 2, that is 8. Then we can have the plot for that graph, our displacement time graph. Displacement time graph for that, we are going to have it this way. Displacement time graph. So we have on the y-axis, we have the displacement, and we have been given the displacement in meters. Then we have on this axis, we have time, and the time is in seconds. So we have time from 0 to 3, from 0 to 3 seconds. So we have 0 to 3, we have 1, 2, 3. So that's what we have. We have 0, 1, 2, 3, 4. Then we have the displacement. The lowest is 2 to 8. So we can have 2 to 8. So we have 0. We can have 4. We can have 6. Then we have 8. So in our case, we have 0. We can have in this 2. We can have 1 up to 8. So this is 1, we have 2, we have 3, we have 4, 5, 6, 7 up to, let's say we have 8 there. Then we plot this point. We have 0, 2. Then we have 1, 4. We have 1, 4. We want to see what the slope is going to give us. 1, 4. Then we have 2, 6. 2, 6. Somewhere there. Then we have 3, 8. We have 3 and 8 somewhere there also. Then we can come and plot this graph. We plot the graph. So this is what we are going to have, and the equation is S is equal to 2t plus 2. That is the equation for our graph there. So in this, we want to get the slope of this graph, because we are saying that the slope of a velocity time graph will give us the velocity. So we get the slope, which is given by change in displacement divided by the change in time. So we get the slope, or the gradient, which is given by change in displacement, that is S, divided by change in time t. So we simply come and get some points here. You can come and get the point here that you want to use. We can use a point like 5. We can use a point like 5, or we can use the one that is already there. We can use these points for accuracy. Whereby we have 4. We have 4, and we have 1. We have 4, 1. Then we can get another point. So we have 1, 4, 1. Then we can get another point. We can get a point like 7. In our case, we can take 7 and get the other point. We have 2.5, around 2.5. So we have 7, and we have around 2.5. So we want to get the slope. So we have here 4 is the displacement, so we interchange because we need to write them in x, y. So we have 1, 4, and then we have 2.57. So this is our x, y, and therefore the gradient will be given by the change in the displacement, which is on the y-axis, that is 7 minus 4, then divided by change in the x-axis, which is the change in the time axis, that is 2.5 minus 1. So we end up getting 3 divided by 1.5. 3 divided by 1.5. So when we divide 3 divided by 1.5, we end up getting our gradient as 2. The gradient is 2. So I want you to note that our gradient is equal to 2. And we have said that on displacement, the graph for displacement against time, the gradient is equal to the velocity. And therefore we can say from plotting the graph, therefore the velocity is 2. On the y-axis we have meters, on the x-axis we have seconds, and therefore it is 2 meters per second. That is the velocity. And I want us to consider the following. I want us to consider from our equation, I want us to differentiate that equation. Now we differentiate the equation, differentiate with respect to t, differentiate with respect to t. So in this case we have our equation S is equal to 2t plus 2, and therefore when we differentiate this, we are going to get ds all over dt, which will be equal to, we have here raised to power 1, so we have 1 times 2, that is 2, and then we have t raised to power 1 minus 1, Then we have plus. When we find the gradient function of 2, which is a constant, is 0. So we are going to have 1 minus 1 is 0, a number raised to power 0 is 1. So our ds dt is also equal to 2. And therefore, you can see the velocity that we got here from this graph, that is after finding the gradient, is the same velocity that we are getting here when we differentiate this equation. And therefore, we can simply come and say, therefore, that when you want to get the velocity, it is simply differentiating this equation, that is the displacement, you differentiate with respect to time. And therefore, velocity is given by ds all over dt.